Chapter 7, Lesson 5, Scale Drawing. State Standard 7, G1, jumping right into vocab right away, looking at scale drawing. Again, a scale drawing would be a drawing that is a proportional, two-dimensional drawing of some sort of object that is too big or too small. Usually talk about how the cell or the cell membrane has been drawn out for you and it's larger than what we can see. So all those pictures of them have been proportionally made bigger for us to view something that is too small. A scale model correctly should say that it is a proportional 3D dimensional or three-dimensional model of an object. So there's scale models of planes and trains and automobiles and buildings and so many different things. Again, everything is proportional. So if you were to take the small Hot Wheel car and stretch it proportionally, it would stretch exactly into a car, the real one in real life, if it is done to scale as a scale model. And then the big thing today, put a box around this word scale. This is what you and I need to find all the time. It's almost like the key, if you will, from geography class. Today we need a scale, and that's going to be a ratio. So we're going to be writing that as a fraction. You're going to see the ratios, and then they could be written as, 1 inch to 5 miles, or maybe they're going to say 2 centimeters equals 13 kilometers. They're going to do something like that. Sometimes they'll even just put little marks like this, and they'll say that being a centimeter or something, 1 centimeter, is the same as 100 meters. So they'll do stuff like that. That's what we're looking for, a scale. It's going to be the key, the main thing that we need. And one of the tricky things we look at is the word scale factor. We're going to take a look at it today. Not one of the big takeaways, but something we need to do. It says without units. Make the note to yourself that means that they're going to have the same label. The last example, we talked about how 1 inch equaled 5 miles, or whatever we said down here on the bottom. And that doesn't work to be a scale factor. If we're going to talk about this down here as a scale factor, they both have to have the same label. They both have to be in inches or both in centimeters. We have to have the same label in order for it to be a scale factor. And we'll talk more about that. When we go to the next slide, this is the big takeaway. This is what we want you to be able to do. It's what's written within the standard, to be able to find an unknown measurement when given a scale and a model or the actual. So again, the scale, this is the big thing, model of layers of crust of Earth has a scale of 1 inch to 500 kilometers. Box that up. That's the big thing. We're always looking for the scale. Everybody say scale. If you say scale, that's what we're looking for. So write it as a ratio. Write it as a fraction. But help yourself out. Off to the side over here, put down in the word inch or the label inch, because on top here, the 1 has the label inches. And then what's the label with the 500? Let's put that down here. The kilometers, again, that's coming from up here in the word problem. You're looking at that. That's just going to help us as we continue on. And now it's going to give us another measurement, something about real life or something in the model. And here it says Earth's crust. So the real thing has 800 kilometers. So again, you could look at it as on top we've got the model and on bottom we've got the real thing. Or what I usually just talk about is, notice the label here. We got to put 80 somewhere. So 80 needs to match the label. Since 80 has kilometers with it, we need to make sure the 80 goes where kilometers is. Kilometers is on the bottom. With the 500, they have kilometers. So the 80, since the 80 has kilometers, it needs to go on the bottom as well. Now we don't know what it is on the model, so put a variable up there. And now we get to use the cross product. More than one way to solve this, but cross products will always work, because then you're going to get this 500x. And then from there we solve and we cross our fingers and hope that it comes out to be something nice on our calculator as we take that 80, the top number, divided by that bottom number 50. Oh, that came out not awesome, but it wasn't too bad. 0.16 equals our x. Now go back up here on top. Find that variable. Since x was on the top, your label is going to be what's on the top. Since the label on top with the 1 is inches, the number we just solved for needs to have that same label. It has to have the label of inches. So either sneak it in down there below it, or right beside it, or rewrite it somewhere. And that is the big takeaway there. That's what we want you to be able to do with scale drawings. Then, on your book assignment at least, oftentimes it's going to say to measure. So we want to be very careful that we get a ruler. So you can see we've got a ruler here. And it says down here 1 centimeter. So we got to make sure that we're using the centimeter side, not the inches. So the one with the numbers closer together. The one that says centimeters, at least on my classroom right now, the rulers I have, we have the word centimeter right here. We're going to measure there, but notice it says between a couple of cities. We want to go from Sacramento, which is right up here. You can circle it if you want to. And then it goes to Modesto. We're just going to assume that that road is perfectly straight for driving purposes. It will work. And then now we stretch that. Now notice with my ruler 0 is listed here. On this example, this ruler has the 0 starting on the ruler. Most rulers have the 0 on the edge, which means the more we use them, especially the paper ones, the more it gets smushed and our accuracy just lowers a little bit. But here we go. We're going to read this and we're going to figure out how many centimeters it is. You can see right here where Modesto is. It's kind of about 1.6 on mine. However, in class when I was teaching this, we all pretty much agreed that that was about 1.5 centimeters. So let me get that decimal in there. With that then, here's what we're going to do. We're going to go over here and we need to start with this scale right here. The scale here. We're going to start with that guy, and we need to write that as a fraction. So we're going to write it as, I want to write it as 1 over 50. The way that you write it actually does not matter, as long as you keep those labels the same. Where again, I want to put that little help up here where centimeters was with the 1 on the top, 50 had the label of miles. Now that equals my other number, which was 1.5. Over here, it's 1.5. So we've got to put 1.5 centimeters where centimeters belongs. And since centimeters belongs on the top, I'm going to put down 1.5 centimeters, 1.5. And you might already be saying, well, Mr. Walls, it's 70, of course. Well, yes, there's more than one way to get there. And this way always works, where you can do the cross product. If you say, well, Mr. Walls, you just multiply these two numbers. You just take 1.5 times 50. Make sure you show that work. You just show me that work, so that way we know where that number came from. Otherwise, there you have it. Again, go back, follow that variable. Since the variable's on the bottom, what was the label with the 50 in the problem and the key? What's the label here on the bottom? Miles. So make sure that we put the label miles, M-I or M-I-L-S, M-I-L-E-S, excuse me, if you want to spell it on out. And that is a lot of the book assignment for this portion, is measuring and then putting what you measure into this cross product or proportional relationship and finding and solving for that. Now, if you are interested in actually going into fashion design, they actually do this. They sketch out, they draw by hand first what they want their outfits to look like. So that's what's happening here. There's a shirt being designed. The drawing of the shirt is 9 centimeters. So let's write the scale. Again, the scale is huge. Box that up, because when we talk about scale, everybody say scale. Did you say scale? Hope you did. The scale is the important thing. It tells us how the real thing compares to the model or the drawing. So in this case, I'm going to start with the drawing, and then now they had to tell us what the actual shirt is, what the real thing is. It is 1 meter. You have written a scale. So now if they said the collar of the neck is 4.5 centimeters wide, how long is it in real life? You could figure that out. Or if the width of the shirt, they could ask you any type of question, and now you've got that scale. Part B here, though, says scale factor. We're going to practice this a couple times and walk through this between a couple of examples and days and practices. Scale factor, make the note to yourself that they have the same label. Now, when we talk about the same label, that means when we go back up here, they both have to be centimeters. Previously, the science class taught these, and converting between metric, sometimes we teach them to ourselves. If not, that's what we kind of have to learn in a sense, that 1 meter and centimeters to convert that. So what I talked about in class was this thing here, centimeters. In a century, there's 100 years, just like in a meter, there is 100 centimeters. So we're going to take that times 100, which I know seems a little silly to ask you what's 1 times 100, but that's where the 100 comes in. Now, just switching 100 meters, 1 meter to 100 centimeters, and then write that original thing down here again, 9 centimeters. Do we now have the same labels here? We do. They're both centimeters, so you write your final answer without the labels. Please note, if you can simplify 9 out of 100, or 9 to 100, if you can take anything out of both of them, you need to do that and simplify that ratio. Here we've got an example of a scale drawing, a miniature glass mosaic tile. So this over here is a drawing of a tile that's actually really, really tiny over here. You can see 4 millimeters that is made and used in a mosaic, so picture. It starts off by saying, find the perimeter and area of the tile in the scale drawing. So circle that up. The whole phrase, the scale drawing, or rather, if we want to, we should just circle up the words drawing. That's this guy. So I'm going to change colors. You don't need to. Perimeter. Find the perimeter. If this side is 4 and this side is 4, how much is the top side? That's right. It's 4, and the left side is 4. So show me the work. A blast from the past, or looks like precursor. We'll be doing this for chapter 9 with volume and surface area, writing that all out, and you get 16 centimeters, as that is the label of the scale drawing. Then it says to find the area. Well, area is length times width. The length of this guy is 4. The width of this guy is 4. So take 4 times 4. Give you 16 centimeters squared. And yes, all that does need to be there, just like I said. Chapter 9, whether a blast from the past or a little future view here, I got to have that formula, the work, the answer, and that label. Make sure those are all there for that. We've now found the perimeter area of this lovely drawing over here. Hooray! And you can see it in front of you when I open it up on the screen here. You can see it now. Now it says find the actual perimeter and area of the tile. In order to do that, we're going to need to figure out how big this is in real life. We need the scale. Everybody say scale. When we say scale, everybody say scale. There's the scale. So if you want to make the note to yourself that this is the scale, we are going to write that down here to start with. Write it down. We've got 1 over 4. If you want to, I would recommend writing that little ratio over here that, the 1 had the label cm and the 4 had the label millimeters. And now, come over here, and this was nice. It told us the side length was 4. Notice it's 4 centimeters. When I write that 4 down, we're going to match that label, the centimeters, over here with the centimeters. And now we can do our lovely cross product where we get our 1x equals 16, and matching that label up here from that x on the bottom. So the label with the 4 from the scale was millimeters. Yay! We now know the bottom We know the side is 16. Don't pack up your notes. We're not done. That wasn't the question. But we can use a little math hack or a life hack here. We know the length down here in real life is going to be 16 millimeters. What do you notice about this side? Well, how would you classify this shape? What would we call this shape? We would call it a square because both sides are the same. Since they're both 4, don't do this work again. It's a square. You only have to do this once. If it was a rectangle or something else, then you'd have to do this work here twice. Once for the length and once for the width. But we know already it's 16. So now you can come over here and you can find the perimeter. It's a square, so all 4 sides are going to be 16 millimeters long. Or taking 16 times 4, whatever it is, show me that work, you get the answer 64 millimeters. And now it says also find the area of this actual tile, so A equals length times width. Yes, you need to write that on in. Take the length, which is 16, times the width, which is 16. So 16 squared, or 16 times 16, gives you 256, but now we're talking about area, so that's going to be millimeters squared. Again, make sure that work is there and that formula is there. One last time, it says compare the ratios. Compare the ratio of the drawing to the perimeter, the drawing perimeter to the actual perimeter. So up here, we saw that the drawing perimeter was 16, and the perimeter of the real thing was 64. So when we go back over here, we're going to compare those guys. 16 over 64 fast. Those are both even, so you could divide them by 2. Always simplify fractions if they're even. If they end in 2, 4, 6, 8, or 0, divide them by 2. Or if you say Mr. Wallace, you can take a 4 out of them. Great. 16 divided by 4 is 4. 64 divided by 4. You use a calculator if you need to, since we're working on it in class. Hey, 4/16, I can take another 4 out of those guys. Cool beans. Simplifies down to 1/4. Hey, that sounds familiar. 1 to 4. That's just like our scale up here. It was also 1 to 4. Sweet. Now it says to find the scale or the ratio, that is the fraction comparing 2 numbers of the drawing area to the actual area. The drawing area right here and the actual area. So we're going to use and pull those guys on in. 16 over 256. Those can be divided by 4, but if you're not sure, they're both even. Divide them by 2. So you get 8, and 256 divided by 2 gives us 128. Again, that's both even, so you can divide them by 2. Mr. Wallace, you can take a 4 out. If you see that, great. Do that. If not, just keep dividing it by 2. That gives you 4 over 64. Those can both take a 4 out of them. So you take and divide them both by 4 if you see that now. If not, take a 2 out. And that gets you 1/16. Hooray! Next year, in course 3, we have this also kind of set up, this correlation right here, where we talk about the area, and our label for area is squared. So if you take 4 squared, if you take 4 times 4, you get 16. And we're going to talk about using that later, but here, just taking a quick glance at it to see how that works, like how it does actually work for next year. But today, again, this is the big takeaway. We want you to be able to say, I can use scale drawings to find actual distances. Yes, we're going to talk about scale factors. That's not the biggest takeaway. Scale drawings to find actual perimeters and areas. You're going to do that. And then it says also recreate scale drawings at a different scale. So you can see those on our scale drawings. And we'll be working on this again. So working with scales and scale drawings, the big takeaway. We want you to be able to say that you can find an unknown measurement using scale drawings in that proportional relationship.